Welcome to our sixth lecture in our standard on the skeletal system. Today's lecture is going to focus on joints, movement, looking at really what is a joint, how do we classify different types of them, and how does movement occur, what are the types of movements that occur at different types of joints. And so as we get into this, I want to start again with that definition of what a joint is, right? All that it is just any place where two bones meet. So whether it is a cranial bone, right, the frontal meeting up with the parietal bones, that's a joint. Whether it is the humerus slotting into the scapula, that's a joint, right? Any place in which two bones meet is a joint, which also means that not all joints are made the same, right? Those are going to behave and be connected in very different ways depending on where they are, what they do. And so really we're going to get to the classifications of these joints and understanding how these joints and their structure fits the function of them. And so in general, right, the function of our joints, we have a bunch of different ones depending on the type of joint it is, but it tends to be twofold, right? Mobility, about moving that area, and stability, keeping that area together. And all joints have both of those to some extent, right? If you think about your elbow joint, it needs to be mobile, right? It needs to be able to move. It needs to be able to have things move across against it. And we also have ligaments, tendons that are locking it in place so that it keeps it together so that there is stability. And so all joints need to have kind of both of these involved. Some have much, much less mobility, but all of them at least need some level of stability. And so we can classify joints in a lot of different ways, right? We have two general ways to classify bones. We can classify them based on their structural classification. So what actually makes the two bones connect, right? Is it made of one connective tissue or another? Is it made out of ligaments, tendons? Does it have fluid in it, right? So physically, what connects the two bones is one way to classify. We can also classify based on function, right? What does it do? Does it move a little bit, not at all, or a lot? And so while they'll kind of mirror each other, you'll see a lot of commonalities between the two. These are the two ways that we really classify our joints. And so we're going to start by talking about classification based on structure. So what actually connects the two bones to one another? We have three types that we really want to know and focus on. And those are our fibrous joints, our cartilaginous joints, and our synovial joints. We'll start with fibrous. A fibrous joint is a joint in which the two bones that are connecting to each other are connected by a dense connective tissue, which means there will be no joint cavities. It'll be what I would classify as almost entirely immovable. When I think about this, I think about sutures. Right? Super easy to see, but what connects them? Well, it's just connective tissue, right? Dense connective tissue. There's no wiggle, there's no movement, there's no sliding. It is locked in there. Same with things like your teeth, right? The root of your teeth locking into place. How does that happen? Well, it's still a joint, right? Your teeth are one bone, the mandible is another joint or another bone. And so to make them slot into each other, right, there is this fibrous joint that locks it in place, no wiggle room, no movement. We also have what is called a cartilaginous joint. Cartilaginous joints are any joints that are connected by cartilage, right? Usually these joints will be a little bit wiggly, a little bit movable, but not overly, right? We don't want a ton of flex in our spine. We don't want to fall over. We don't want a lot of flex in our rib cage, right? We don't want, if somebody pressed on our sternum, for it to like push into our heart. And so this will still have that like connective tissue. It'll just be a cartilage connective tissue. And it'll limit the amount of movement, right? And no real joint cavity, just discs of cartilage or pieces of cartilage connecting one to another. And then our last one is our synovial joints. Right? These are the ones that we think of the most when we hear about joints, when we think about joints, because these are our freely moving joints, usually because they are separated with actually like a fluid-filled cavity, right? It's a cavity that's almost injected with like it's called synovial fluid, but it's almost like an oil that makes sure that there's limited friction. So it's actually set up to facilitate a ton of movement. And synovial joints you'll see primarily in things like your shoulders, elbows, ankles, hips. All those are going to be synovial joints. And so that was our classification based on structure, what actually connects the two. Now we're going to classify based on function. So what do they do? How much do these joints move? That's how we'll classify them instead. And so we have what are called synarthroses, amphiarthrosis, and diarthroses. Right? So these are really tough to say, and we'll tend to use the synovial fibrous cartilaginous more than we'll use these because they kind of do go hand in hand, but it's important that we still know these, that we still have an idea on the general makeup and what these concepts are. So we'll start with these synarthroses. They are usually connected by fibrous tissue, and these are non-movable, right? That's the idea. Skull sutures, the teeth, they don't move. Because they don't move, they're synarthroses. Amphiarthrosis are kind of moving. They're a little bit here, a little bit here, right? Slightly movable. Usually these will be made out of cartilage. It's not always, but because they have a little bit of flex, a little bit of give, and cartilage is what allows that, these are classified as amphiarthrosis or slightly movable joints. And then finally, we have the diarthroses. These tend to be our synovial joints. All synovial joints will fall into diarthroses. And these are classified as freely moving. And when we say freely moving, we don't mean they can move in all directions. We mean they are designed to move. And so any joint where movement is intended, so whether it be your hands, whether it be in your ankle, knees, hips, all those are going to be freely movable. They were designed to move and therefore will be diarthroses. And so this structure-function relationship is really important. I wanted to teach you guys both the words to understand that really, while yes, they're different classifications, we can put them into the same general categories, right? Your synarthroses are usually going to be your fibrous joints. Your cartilaginous joints are usually amphiarthroses. Your diarthroses are usually synovial joints. So just understand that the structure is the function here. What it's made out of is actually how it's classified based on function. If you're made out of synovial tissue, right, between the two bones, it's probably going to be a diarthrosis. And so just make sure to connect those two in your brain because they really are going hand in hand here. And so that was our classification. Now, we're going to talk a lot more about the synovial joints because those are the ones that are designed to move, intended to move, and as we transition to the muscular unit, these are the ones that we're going to continue to kind of call back on. And so we're going to break down what actually goes into a synovial joint, what makes up a synovial joint, and what are the parts that you should know are included within a synovial joint. And so first is our joint cavity. If you look on the image, I don't have a super clear diagram for this, but the joint cavity is just the space, the pocket between the two bones that are connecting, right? It will have a fluid within it, which will be called synovial fluid. And big idea on this is just that our goal of our joint cavity is just to leave some space between the two so that we can put that fluid in to make sure that there's very little bone-on-bone rubbing. Because the more bone-on-bone rubbing that we have, the more bone chips, the more bone spurs that will form, and the more inflammation that we'll have in the area as a result. And so the joint cavity is basically like a little fluid-filled space in between the two bones. It's like a sac because it is enclosed that makes sure that those two bones can't rub on each other. Articular cartilage we're going to find not in the joint cavity, but right on top of the bones as they reach up to that joint cavity. If you look on the image that we're taking a look on next to me, you'll be able to actually see that articular cartilage in the like little tiny blue layers that go right over the head of the humerus before the green and right on the edges of the acromion and clavicle, right? It's that like little blue space. Again, it's just about reducing friction. So even though we have that like fluid-filled sac, we also put cartilage on the sides too just because we need to make sure that there's really no friction at that joint, right? Whenever people are like, oh, it's stiff joint, or they feel like something's rubbing, that's not by design. Movement works best in a low friction environment. And so lower friction means better, smoother movement. So the synovial fluid, if you look in that like green pouch, that's actually what we're gonna find in that green pouch. It's just a like slippery fluid, again, lubricates, make sure that no friction, no rubbing can occur at the joint. Ligaments we're gonna see kind of across the board. Depending on the joint that you have, you'll see more, less ligaments. I always like to talk them on the knee joint, right? Because they're easy to see. But ligaments are just there to connect the bone to bone. Even though we have those pockets, right? To make sure that that friction is limited, we also need to lock it in place, right? Keep it pressed up in the gap so that no matter what, everything's working as intended. The ligaments are just there to stabilize and limit so that we don't overextend, push it outside where it's supposed to go, or unintentionally knock it loose of that joint cavity. And so ligaments are really important to keep us all condensed and staying in place. We also have the tendon sheath. We've got tendons, right? So this is your patella, but like tendons are what connect a muscle to a bone. And so if you're thinking about like your Achilles tendon, what you'll see is that there will actually be a little like sheath or a little like tube, almost like the outer wrapping on like an iPhone charger, that'll go around the tip or the like top part where it's gonna connect to the bone. And this is, again, limit friction, right? We basically are going to put a wrapping around that tendon so that there's no risk of that tendon potentially rubbing and maybe cutting into something or damaging any of the other structures around. And so the tendon sheath is just a wrapping that we can put around the tendon to make sure that it's not being pressed on in any harmful way and it's not pressing on anything in a harmful way. Again, it's just about protecting. It's about wrapping so that we can make sure everything's localized and doing what it's supposed to do. And so that's our synovial joint. That's the big picture stuff we want to know about that. Now we're going to talk about the types of these synovial joints and the movement that occurs at those joints. So our first type of movement that we're going to look at is that of a plane joint, right? And so in your hands, right, at the carpals, so down in this lower section of your hands, is where you're going to find those flat bones. And all that those flat bones are doing is just moving slightly on each other. They just rub a little bit. And that slight rubbing, that slight movement and shifting is what allows for the fingers, right, to have different angles, different approaches. And that's what allows us to really angle our hands to do more fine motor movement. But it's a gliding at those plane joints. You'll really only see them between short bones, though. We have very few plane joints in our body. We really only see them in the hands and in the feet. Our next up is a hinge joint. Biggest ones for you guys to remember and know are the elbow and knee, right? I think those are the easiest to see. A hinge joint is going to open like a door, right? It has a way open, it has a way closed, and there's mechanisms that are preventing it from over-opening, mechanisms preventing it from over-closing. So with a hinge joint, just think about your elbow, right? It can open, it can close, but it only moves in one real direction, right? On one plane of direction. It can't necessarily go to the side, right? This movement to the side is in your shoulder. And so this hinge joint just opens and closes, same way that your knee joint will do. We also have a pivot joint. Pivot joints are a little bit hard to see, but all that a pivot joint is a joint in which one bone moves and slides around another bone. And so we'll see this in our arms. I can show you guys in class if you're feeling a little iffy on how it works in the arm. But it's really easy to see in your atlas and axis vertebrae, right? Those top two vertebrae. Because the atlas is designed to stay put and the axis is designed to turn, that turning of one bone on another, the turning of the axis on the atlas, is a pivot joint, right? One bone, one rounded bone, rotates around another, okay? And so it's just one rotating on the ring of another. And so this movement is a pivot. We then have condyloid. Condyloid is a really, really hard one for a lot of people to understand because it is about like an oval shaped. It's very similar to a ball and socket joint, but slightly different. It basically will do everything but rotate. And so when you think about like your wrist joint, right? The wrist can go left and right. It can go forward and backwards, but it doesn't really rotate around. It gets stuck, and then here it just goes backwards. So see how it's not like actually rotating over this because it can't. It physically can't get past the styloid processes of the radius and ulna. Those lock it in place, and so it goes forward and backwards. It goes side to side, right? I can do waving side to side, but it can't do rotation, and that inability to do rotation is what makes it into a condyloid joint. Really hard to see, hard to tell when you're looking at a condyloid and when you're not, but just really understand that it's about free movement with the limitation of rotation. Think ball and socket, but no arm circles, no rotation in it. We then have also in the hand what is called a saddle joint. Saddle joints are weird because there's really only one. It's just the thumb joint. So if you see on the image, right, what a saddle joint does is it gives basically a like rounded edge, and it allows for the bone to sit in it and move in a variety of directions against the movement of the other bones. So basically, what allows your thumb, we call our thumbs opposable thumbs because they can work against the other fingers, right? They can move in directions against the other fingers. You can't do that with like even any other fingers. They don't work against each other. Only the thumb and the other fingers. It's because the thumb joint will basically have the ability to cross over the palm. It has that ability because it's in a saddle joint. It's basically locked into that joint, and it can only turn on that joint. And so that's what allows our thumb to move up and over. That's what allows it to go against the other fingers. You really only have saddle joints in your thumb. And think opposition when you think about this. Really, I want you to know that the saddle joint is about moving against the other joints, against the direction of the other joints to allow for opposition, to allow us to close. And then our last one here is our ball and socket joint. Ball and socket is one that I think is really easy for us to understand. These are the joints you think most about, right? That's your shoulder, that's your hips, and you have balls and sockets in your hands. But really all I want you to know is ball, right? So circular head of a bone fits into the socket, right? A divot, an indentation in another bone. And that's what allows one to move in the other. And it's going to be multi-directional, including rotation. So it's the addition of the rotation here. It's the ability to do arm circles that gives this ball and socket a little bit more than the condyloid had before. And that is it for this standard. That is it for this unit in terms of new material, information. Good luck in your studying. Good luck getting ready for the test. And feel free to drop any questions, comments, anything that you need down below or in our Google Classroom. Have an amazing rest of your day, and I will see you all in the next video for the next unit.